The third step that we need to do is the surface treatment. The surface treatment involves the compacting the bottoms of the excavations. You see, we have excavated the trenches. We have to compact the bottoms so that that soil can be compact, so that now we can come and support the sides of the trenches. Then we can start construction. Alright, so to compact the bottom of the excavations, it's always measured in area. So we'll start with the compacting of external wall trenches, the bottoms. So if we have the section here, the section for the external wall, it is, the width is 750. Now that it's 750, we will take the center line of the external wall, then we shall multiply by this width so that we can be able to find the area at the bottom of the trench. The center line for the external trench was 39.69. Then the width was 750. So when we are feeding it in, it shall be 39.69 times 0.75. The center line of the internal walls was 6.70. Then the width was 450. Alright, so we shall take the center line, it was 6.70, then the width was 0.45. That one, these two will give us the total area. The first one was for the external wall, the second one is for the internal wall. Alright, so after that we will move on to the fourth step, which is not the fourth step, and still the surface treatments. After compacting, we will do the earthwork supports. You know, this soil is prone to collapsing, so we need to support the sides of the trenches so that they don't collapse. The support is measured in terms of area, because we shall use the formwork. So if this is the section, and we have the trench here, we need to support the sides of the trenches so that they do not collapse. Alright, so how do we measure that one? The earthwork support is usually measured in terms of the area. So, we shall take the area of the faces of excavation less than or equal to 1 meter maximum depth. Distance between opposite faces, it should be less than or equal to 2 meters. Alright, these ranges usually help us because in case it is greater than 1 meter, the rate will be different with less than or equal to 1 meter. In case the distance between opposite faces shall be greater than 2 meters, the rate should be different from the one with 2 meters or less. So you have to specify here, is the maximum depth more than or less than 1 meter? Then is the distance between the two opposite sides greater than or equal to 2 meter, or is it even less than that? So when we are ours here, it is, you see, the depths, the depth of the external trench was 0.75, so it is less than 1 meter. The depth of the internal trench was 0.55, so it's less than 1 meter. Then the distance between the two faces, we shall get it from the section. You can see from the section, for the external trench, the width is 750. The width of the internal trench is 450. So these two, they are less than 2 meters. That's why here we have written less than or equal to 2 meters. Alright, so what is the area? The area of the walls of the trenches is usually measured in terms of length times height. You see, a trench is usually like this. It's U-shaped. We need to support the soil this side and this side. Now, because we have the center lines of the internal walls and then the external walls, if we have this trench for the external wall, we will take the center line, then we shall multiply by the height up to the stripped level, multiply by 2, because we are supporting this side and this side. Then we'll come to the internal wall, take the center line, multiply by the height and up to the stripped level, multiply by 2, because we are supporting both sides of the trench. Then we need to support this soil, which will be reinstated, which we had removed the topsoil, which was 150. We need to support this side of the trench so that you can be able to reinstate the soil. All right. So how do we find the area of the? We start with the external walls. We shall start with the center line of the external trench, multiply by the high depth up to the strip level, then we multiply by 2 sides. For the internal walls, we'll take the center line of that wall, multiply by the height up to the strip level, then we multiply by 2 sides. Then, now for the reinstatement, we shall take the center line of, not the center line, this side. You see, once we draw a straight line like this, we need to support here and here. So we need to support this face all around the building. Using the plan, you can see where the trench is passing through. So here we will come supporting all around at a depth of 150. So what is this perimeter all around? The perimeter all around outside the trench, you can either use the dimensions here up to here, here up to here, going around, or you can take the center line of the trench. Then you see, to find the center line, we took the external dimensions, then we deducted the number of corners times the width of the trench. Now, because we have the center line, we shall add the number of corners times the width of the trench. So having a center line of 39.688, we shall add number of corners, which is 4, external corners minus internal corners, then we multiply by the width of the trench. The width of the trench is 750, so it shall be 3 meters. So the external perimeter of the trench shall be 42.88. So the area of the face of the trench that will be reinstated with the soil shall be 14.269. This one rounded off to 2 decimal places. Then we multiply by the depth of 0.15 for the topsoil. So this is for the external wall, outer face of to retain topsoil. Then here we shall deduct the detail. We shall deduct the area for the faces of the trench where we have intersects. What do we mean? You see, in a trench, the trenches are like this. They are where we have the broken lines. Where the external walls meet the internal walls, we do not support this space because already we have supported the soil from here up to here, from here up to here. Then we'll need to come and support from here to here. But when we took the center line, then times height times 2, we accounted even for this place where we will not do formwork, and also for this space. Now this place where the external walls trench intersect with the internal trench, we shall have to deduct this area. So we shall take the width of the internal wall, internal trench, then we multiply by the depth. Then we take the width of the internal trench, then we multiply by depth. So it is the width of this depth of the trench multiplied by the depth multiplied by 2. So this is the width of the trench, because if we look at the section, it shall be 0.45 multiplied by the depth, which is 0.55. Then we multiply by 2. The next item, we shall go to disposal of surface water, which is taken as an item, because this one we cannot measure it from the drawings. So we'll have to do a provisional sum in the BQ, which we shall get from a specialist who dewaters the sites. Alright, now we shall continue to the first step, which is calculating the volumes of the in situ concrete.